because it's x to the first power, and we can solve it just like you would always want to solve something. What are we going to do first to solve this equation? What are you going to do? Yeah, we're going to distribute the negative 5. So we distribute that negative 5 through, we get a 2x, we get a minus 5x, we get a plus 5, and that's equal to 3x plus 2. Now we can simply gather our like terms. Notice that the 2x and the negative 5x make a negative 3x plus 5. And on the other side, we have a positive 3x plus 2. I'm going to gather my x's on the left. You can do the left or the right. It's up to you. Negative 6x plus 5 is equal to 2. And I subtract the 5 to get negative 6x is equal to negative 3. Divide by negative 6. X is 1/2. Suppose I wanted to check my answer. What would I do? You'd plug it in. We've all seen those examples before, right? It's important for us to press ourselves a little bit further. I haven't put 8 examples here because I know you already know how to do that. What I'm worried about is, do you know what to do if you encounter a fraction? For example, here you know to add 6 to both sides to get 3/2 x is equal to 27. But do you know what to do from that point? Multiply by the reciprocal. So I'm going to multiply by 2 over 3. Now, I still get to points where people are like, I don't know how to multiply that by 2/3. It's really not that bad. Watch. You can either take 27 times 2 and divide it by 3, or you can take 27 divided by 3 and then multiply it by 2. 27 divided by 3 is 9, times 2 is 18. So you can do it in either order you want. Multiply by the top, divide by the bottom. Viv, would you agree that if you could make fractions just go away, you would? If you could make fractions just disappear from every problem, would you do it?
Yeah.
I would too. And I'm going to teach you how to do that right now. I'm going to make the fractions just disappear because I don't like to work with fractions. I find them cumbersome and confusing and frustrating. And they're very frustrating for me to teach with because people lack skills of working with fractions. So I'm going to do something here, but I need you to follow this logic. If x is equal to 2, is it also true that 5x is equal to 10? Are those statements equivalent? Yeah. They are. Notice that I multiplied both sides by 5. You are allowed to do that with equations and maintain equality all the way through. So let's look at this. I'm going to multiply through by a number, and it will get rid of the fractions. Anybody know what number I multiply through by to get rid of the fractions? Hint, it starts with a 1.
15.
15. Why 15, sir?
What?
Why 15?
Because it's the common denominator of both fractions.
Yes, 3 and 5 both divide evenly into 15. It's what we refer to as our least common multiple. It happens to be the common denominator as well. Watch what happens when I multiply by the 15. This is 15 over 1. I take 15 divided by 3 is 5 times 4 is 20. 20G, or like 20 grand. It's like my bank account, right? Well, you don't think I got that much money, huh? Plus, now 15 times 12, 180. And now in the end, 15 divided by 5. Again, I divide by the denominator. I multiply by the numerator. 15 divided by 5 is 3. Times 2 is 6. Now I'm going to argue that that equation is now easy to solve compared to the first one. So if you have fractions, feel free to multiply through by something in order to get rid of that denominator. I subtract the 20g over, I get 180 is equal to negative 14g. Divide by negative 14. Notice they are both divisible by 2, so I have negative 90 over 7 is equal to g. Don't be surprised to end up with numbers that are difficult to plug back in. Okay? Is that a question? All right. D, what number would you multiply through by here? 30, because 5, 3, and 2 all multiply to 30. Now, you could multiply the top through by 30 and divide by 5, but I find it easier to take 30 and divide it by 5 and then multiply by the result. So 30 divided by 5 is 6, so I distribute just 6 through the top. 6 times 3x is 18x. 6 times 2 is 12. Now we move on to the next term, this 1/3. 30 divided by 3 is 10, so it's a minus 10. 30 divided by 2 is 15, times 5 is 75. And 30 divided by 3 is 10, so we have a plus 10 on the end there. Sorry about that, I'm running out of space. Plus 10 on there. For the sake of time, can everybody agree that we don't really need to practice solving that? You're really good at that, right? If you weren't good at that, you wouldn't be in this class. So let's set that aside and look to a more interesting example. Today we want to get through example 3A. We need these. First, we need to talk about the zero product property. Suppose that it is not x to the first power. Suppose it's a different power. What do? We have this beautiful piece of logic. Again, mathematics, stop thinking about it as something like we just tell you what to do and you do it. Let's use some logic here. And the logic that comes is this. If A times B is equal to 0, then we know something to be true. If A times B is equal to 0, then what do you know? Excellent. Evie says then A is equal to 0 or B is equal to 0. We know that one of those things is going to be true. That doesn't work with any other number, right? I mean, suppose you had A times B was equal to 24. Could you say anything about A or B? Absolutely nothing. You're like, well, one has to be 3 and one has to be 8. Really? I mean, could it be 2 and 12? It could be 1 and 24. It could be 4 and 6. Or how about this? Could it be 96 and 1/4? Oh, yeah. There's an infinite number of different numbers it could be, right? But when you have the zero product property, you only have one option. Either A or B must be 0. Lights out. So we invoke the zero product property. And so in this situation right here, notice how we have 0 on the right-hand side. And we have a second degree equation. So if we can write this as multiplication, notice how it's written as times, it is factored, then we can solve this. So what does it factor to? Good, x minus 5 and x plus 3. The first binomial would be my A value, and then the second one would be my B value. So if x minus 5 was equal to 0, then x would be equal to 5. And if x plus 3 was equal to 0, x would be negative 3. And those are my two solutions. This whole time, I'm like, Mr. Getz already knew how to do that. Then why do I see these mistakes on the test if you are also confident? Why do I see people do this? Oh, I know how to solve that. I just factor an x out. Then I got 6x minus 1 is equal to 5. Yeah, so I got like x is equal to 5, and I got like 6x minus 1 is equal to 5. Yeah, I'll just solve both of those. That's called voodoo math. Okay, that's just made up stuff. That doesn't work. You just made something up. There's no 5 product property. There is a 0 product property. 0. So what do I do first? Yep, subtract 5. 6x squared minus x minus 5. Because we honor the number 0. It has power above all other numbers. Very special number. Okay? And I try to factor this. Then we're going to see how good your factoring skills are. Any guess? You think it's going to be a 6x and an x or a 2x and a 3x? What do you think? It is a 6x and an x. Nice job. Somebody ate their Wheaties today. Do people still eat Wheaties? Is that a thing? No. Okay, never mind. We did. All right, okay. All right, we'll start a thing. Yeah, I like it. We got -5, so I think I'm going to go with a +5 and a -1 out of this deal. Does that work? It does. So x is equal to two different numbers. I have -5/6, and I have +1. What do you think? Not too bad? Okay. How many solutions did we come up with here? 2. And what degree is the equation?
2.
How many solutions do we get here?
2.
What's the degree of the equation?
That was
2.
the bottom one.
Look at the previous equation. Look at this one right here. How many solutions did we come up with for our very first problem? We came up with 1, right? I erased it, but it was x is equal to -1/2. And what's the degree of it? 1. There's this beautiful thing in mathematics we're going to study in chapter 3. It's my favorite thing to talk about in this college algebra course is the fundamental theorem of algebra, which states that if you look at the degree of the equation, that tells you the number of solutions. Now, there's a little caveat to that. It doesn't always work for us the way that we want, but this should predict that we should get how many solutions? We should get 3. So how are you going to start by finding your solutions here? Is set equal to 0? What are you going to do first?
Simplify
How?
so that we can have x
Okay.
out of both.
So you're going to take an x out of both. So I factor out the x. I'm left with 4x squared minus 1. X times 4x squared minus 1. Does 4x squared minus 1 factor?
Yeah. Difference of squares.
Difference of squares. X times 2x minus 1 times 2x plus 1 equals 0. I said I should have 3 solutions. X is equal to, what are my 3?
0, -1/2, and 1/2.
Whoop. Sorry about that.
All good.
I'm getting careless here. When I record, it slows down my screen and it causes problems for me. I got to be a little bit more patient with it. Okay. Just to be clear, the 0 comes from the x out here. If there wasn't an x, suppose there was just a number like 9, that does not mean that we put a 0 there then. Okay, it has to be a variable. Okay. All right, 2 problems left. What do you want to do first for problem D? Hint, it's in the zero product property section. Put it all on one side. X cubed minus 2x squared minus x plus 2 equals 0. I get it equal to 0. If I can do that and factor it, then we're in good shape. I wasn't here this day. You watched this lesson online. So you tell me, what do I need to do? What factoring method works if you have 4 different terms? Grouping. I never put grouping symbols in front of a subtraction sign. So I'm going to write this as plus negative. I'm sure I did that in the video for you. So I'm going to group the first 2, and I'm going to group the second 2. What can you factor out of the first set? X squared. And you're left with x minus 2. What can you factor out of the second set? A -1. So I factor out a -1, and I'm left with x minus 2. All right, what do those now share in common? Good, and when you factor it out, you're left with x squared minus 1 is equal to 0. And the x squared minus 1, so nicely, is the difference of 2 squares. I have x minus 2 times x minus 1 times x plus 1. Can somebody tell me my 3 solutions?
1, -1, 2.
Good, plus or minus 1 and 2. So those are my 3 solutions. Okay, last example for the day. It says solve the following by completing the square. Completing the square. This is a little bit different process. One we really need to lean into is we complete the square here, okay? We have x squared minus 2x minus 5 is equal to 0. Does that factor? It doesn't. If it doesn't factor, then completing the square, or then the zero product property doesn't work so well for us, and we turn to a different option. You need to know how to complete the square. x squared minus 2x, and what we do is we move the 5 over to the other side. We make room so that we can turn this from just a normal everyday trinomial into one that is a perfect square. Now I'm going to give you an example of a few trinomials that are perfect squares. X squared plus 14x plus 49, that's a perfect square because it factors to x plus 7 quantity squared. I'll give you an example of another one. X squared plus 12x plus 36. That's a perfect square because it factors to x plus 6 quantity squared. So you tell me, if I had x squared and I had plus 8x right here, what number would go on the end to make that a perfect square? 16. How'd you get 16? Okay, you took 8 divided by 2 to get 4, and then you squared it, right? So you take this, look, 12 divided by 2 is 6, squared is 36. 14 divided by 2 is 7, squared is 49. 8 divided by 2 is 4, squared is 16. So we take the middle, we divide it by 2, and we square it, okay? So good for you guys for seeing that, being able to figure that out. For some people, it's a little bit challenging. You guys have it. Way to go. So let's do it for this problem. Negative 2 divided by 2. Negative 1 squared, 1. So you add 1 to complete the square. Now that's a perfect square. In order to maintain equality, if I added 1 to the left side, I add 1 to the right side. And so now you have x squared minus 2x plus 1. That does factor, and it factors to x minus 1 quantity squared is equal to 6. How do I get rid of the squared? Square root both sides. If I square root both sides, I'm left with x minus 1. Now, because it's an x squared, how many solutions will you have? 2. So you need to list plus or minus the root of 6. That's how you come up with your 2 solutions. And to finish this off, we simply add 1 to both sides. X is 1 plus or minus the root of 6. And there are your 2 solutions. We're going to pick up with letter B on Tuesday, along with the rest of it. That will finish off the unit for us. As you glance at your homework, the question is, what can you now work on? Well, you're at the 1.5 section, which is solving equations, linear and quadratic. Some of these linear ones should go pretty quickly. And then if you look on the back side, I do have a couple that involve completing the square. So you should be able to work on some of that. You had 12 minutes, which isn't bad. Last hour had 4 minutes because we had the lockdown drill. And third hour didn't get class today because they had to sign up for college in the schools courses. So once again, the lucky 8th hour.